Hi, this is Timothy Brusella doing some more implicit differentiation for my Math 1325 class. Here's a word problem. And that print is sort of small. So a casino hotel manager has approximated demand for 2-room suites to be P equals 8,000 minus Q squared over 24, where P is the price in dollars and Q is the quantity demanded. Use implicit differentiation to find and interpret dQ dP when Q is equal to 6. I'm glad we have one of these problems because so far all we've had for implicit differentiation, everything's in terms of x and y. Well, which variable is acting like the x in this case? Well, because that variable, when you differentiate it, you don't stick on the prime. Which variable will you have to stick on that prime for? So for a moment it looks like, well, this is, I suppose you could say it's explicitly solved for P in terms of Q, but we want the derivative with respect to P. So that's what we need to, you need to be making a note of this. In this notation, that variable there is the variable in the denominator. That's the variable you're differentiating with respect to. So we're going to differentiate this function. We're going to find the derivative of Q with respect to P. So right here, I'm going to be differentiating, and that little subscript I put is a P. I'm differentiating with respect to P. And that's significant because the derivative of P with respect to P, that's just a 1. You don't stick on a P prime there because that P is acting like the X. And when you differentiate an X, you don't stick on an X. But when you're differentiating an X with respect to X, you don't stick on a prime. So that variable in the denominator, that dQ dP, that's the variable with which you're differentiating with respect to. So the derivative of P is just a 1 equals the derivative of 8,000, that's a 0. And now we need to differentiate minus Q squared over 24. Remember how I think of that, okay? I'm bringing down the minus. I generally just think of that as a 1 over 24 times Q squared. So you bring down the exponent, 2 times 1/24, that's 1/12. Subtract 1 to give a Q to the first power, but Q is some unknown function defined in terms of P. We could solve this equation for Q in terms of P. It'd give us a messy thing, but the easier thing to do is just implicit differentiation. When you differentiate the P, you don't pick up a P prime. When you differentiate the other variable, you do pick up that prime. So let me clean that up a little bit. We have 1 equals negative 1/12 Q times Q prime. First thing I do is get rid of that fraction. I multiply both sides by negative 12. Multiplying both sides by negative 12. So I'm going to get rid of that negative there too. I'd have a negative 12 times 1, which is negative 12. Here, the negative 12, the negative 1/12 is going to cancel with that negative 12. So we're just left with a Q times Q prime. This is falling out pretty nicely. Now we need to solve for Q prime. Realize Q prime is that dQ dP. So we divide both sides by Q, divide by Q, and that says Q prime is equal to negative 12 divided by Q. And they want us to remember the problem. This gives the price, it relates the price of a 2-room suite in Vegas to the demand. Now if the price is high, sorry about that, the lights turned off automatically. They didn't detect that I was in here, so Coming back to the problem, if the price is high, then the quantity demanded should be pretty low, and vice versa. So they want to know what's the price, what's the rate of change of the number of suites they're renting out with respect to price when Q is equal to 6. So we come over here, Q is equal to 6. We get Q prime equals, we're plugging in a 6, that's a negative 12 divided by 6. Oh, that's a negative 2. So at this point, when they're renting out 6 of those suites, that price they're charging, we expect the quantity demanded to be decreasing by 2 suites. And I'm looking here at the A and B options. I hope y'all can read this. So that derivative's negative, so demand is falling. Demand is falling. Which one of these says demand is falling? A or B? A. The quantity demanded decreases by 2 suites a night. And inside that blank, we have a negative 2. At the given price, the quantity demanded is decreasing by 2 suites per night. If the price is increased by $1, the quantity demanded is going to fall. Any questions there? Oh. Well, let's see if we have, there's another one here. And let's see if y'all can read that any better than the first one. Once again, small print. For a certain company, the relationship between revenue in billions and number of employees in millions can be approximated by R squared equals 18,000 times N cubed. Find the derivative of R with respect to N. So if the derivative of revenue with respect to the number of employees when N is equal to 1.8 and R is equal to 324. So in this case, they have what? 1.8 million employees. How quickly is the revenue changing when they have 1.8 million employees and the revenue is at that point $324 billion? Is the revenue increasing? Is it decreasing? So let's see. I've written the problem down here. So we're going to find the derivative with respect to, you tell me. One of these is we're going to either have an R prime or an N prime in this derivative. Which one are we going to have? We're differentiating with respect to what variable? Look at the notation they gave us. We're differentiating with respect to N. That means when you differentiate an N, there's not going to be an N prime. N is acting like the X. When you differentiate R, it's different from that letter there. So you're going to have an R prime. Differentiating R squared. Bring down the 2, subtract 1, multiply by R prime, equals. Here we're differentiating an N. There's not going to be an N prime. That's the variable. That's as if that were an X and an X. 3 times 18,000 is 54,000. Subtract 1 to get an N squared. Coming back to this differential notation here, dr dn, that denominator is what tells us the variable we're differentiating with respect to. And that's significant because when you differentiate an n, you don't pick up an n prime. If you differentiate any letter other than an n, you pick up an n prime. So I would divide by 2r, we're getting r prime by itself, to give me r prime equals 54,000 n squared all over 2r. We wanted to find the derivative, we did, but they want us to determine the value of that derivative when n is 1.8 and r is 324. So you're going to have to plug in 1.8 for n and 324 for r. Uh-oh, I don't know if I remember to bring my calculator here with me. So that's 54,000. Let me move it down. 54,000. N is 1.8 squared. R is 324. And all I have is this. I don't have my TI-83 with me. And punching in, I'm getting a 270. Oh wow, that's good. Why am I saying that's good? That's a positive number. So when their revenue is 324 billion and they have 1.8 million employees, their revenue is increasing at a rate of 270 billion per additional, I guess it would be per additional million employees. So if they added more employees, they would be more productive. They'd have their revenue would increase. I guess I bet you their costs would increase dramatically though. Remember, just because you have a nice revenue, that doesn't necessarily say anything. They may have a $600 billion cost at that point. So anyway, any questions? Okay, I'm going to take a break. Bye-bye. Oh, but before I do, I want to make a note that anytime you're differentiating a variable with respect to a letter that's different from that variable, that's when you have to multiply by the prime. Suppose that had been a t. If that had been a t, neither of these letters are t's. That means you would have had an r prime, and when you differentiated n, you would have had an n prime. That's what we're going to be doing in the next homework assignment. We'll be differentiating with respect to a third variable, t. So in that event, every time you differentiate, you're going to have to multiply by the derivative, the prime notation. Okay then, bye-bye.